Hi, welcome back everyone. So in the last video, we basically talk about what is an bias estimation for population variance and what is an unbiased estimation of population variance. So before we look into one example, um, perhaps one should take note of the following. So previously I wrote Sn minus 1, or usually you just write Sn. So this is the unbiased population variance. This particular equation is given by this. So n minus 1 sum of I equals to 1 until n, xi minus x bar squared. Oh, sorry, the square is outside. So previously this is the equation that we did. So actually you can sort of like expand it, because the unbiased estimation of population variance is given by this whole equation. So this is xi squared divided by n, and then you have this x bar squared. So this is basically the equation for variance if you separate out the component inside the square bracket. So what you can do is to multiply the n inside to get back something like this. So these two equations are similar, and it will be very useful for you to use the second equation sometimes when you do the exercise. So let's look at one example for unbiased estimation. So if let's say you have this particular set of data, you want to find the unbiased estimate of population mean and variance. So for population mean, basically this is your sample mean, and you sum everything. So 1 times 24, 2 times 32, 3 times 29, 4 times 9, 5 times 6. So this whole thing you divide by the sum of everything, I think, is 100. So 30 plus 40 plus 30. Yes, it's 100. So this will be equals to 241 divided by 100, which is 2.41. So I've done the calculation beforehand. I think as long as the numbers that I key in is correct, the answer should be correct. So that is your unbiased estimate of population mean. So what about your unbiased estimation of variance? So that would be your S squared. So according to the formula that we derived just now, you have 1 divided by n minus 1 multiplied with the sum of xi squared minus n x bar squared. So we are going to use this formula. So 1 over n minus 1 will be 1 over 99. The sum of xi square, basically what you did is 1 times 24, 2 square is 4 times 32, 3 square is 9 times 29, 4 square is 16 times 9, 5 square is 25 times 6. So this is the sum of xi square minus hundreds times your 2.41 squared. So this is what you need to calculate. Once you calculate everything, that should be 1 over 99 multiplied with 707 minus 100 times 2.41 square. So this will roughly gives you 1.275. So that is your unbiased mean and variance. So now let's look at hypothesis testing. So basically the procedure for hypothesis testing will be the same. The first thing that you need to find is whether or not this is a one-tail or two-tail test. And then you need to check whether or not this time you need to calculate the unbiased estimate of population variance or not. Once you did that, you formulate your hypothesis and your null hypothesis and your alternate hypothesis. Then based on whether or not this is a one-tail or two-tail test, you calculate accordingly the probability. Finally, you compare the answer of your probability with your significance level and see whether or not you should accept your null hypothesis. So let's look at this particular question. Question number 2. IQ test scores are normally distributed and designed to have a mean score of 100, and now believes that the mean is higher than 100. So just by this particular sentence, you know that this is a one-tail test. She sampled 180 people of IQ test score and summarized as follows. So they give you sum of x and sum of x squared. So before you carry out the hypothesis testing, basically what you need to do is to find your population mean, which is 18432 divided by 180. So this will be roughly 102.4. You also need to calculate your unbiased estimate of population variance, which is 1 over 179 times sum of x squared, which is 1926709.4 minus 180 times 102.4 square. So once you calculate this, you find that this is 219.4. So this is your unbiased estimation of population variance. So let me write this down. Remember that right now we are doing sample mean. So now, what is our H0, the null hypothesis? We state that the population mean should be 100. Always remember that your alternative hypothesis is the one-tail test that you want to do. So H1 will be the population mean is greater than 100. So now you conduct your hypothesis testing. Basically your sample has to be greater than 100 in this case. So this you can convert back to z-score. So now there's you need to be slightly careful of what are the numbers that you need to plug in. So because you are testing your sample, so you are also using the sample mean. So it means that the value that you are testing is basically 102.4. This is your x bar minus 100. And then you divide the whole thing. So now the reason why I highlight that S squared is your unbiased estimate of population variance is because you do know that for sample mean, for example, so this is for sample mean. your x bar is equals to the population mean, and your standard deviation or your variance of x bar is equals to the population variance divided by there's no square root and number of samples. So S squared is the estimate of population variance. That's why over here you should use 219.4 divided by the number of your sample, which is 180. So once you calculated this whole thing out, you find that your P, the Z score is 2.174. And if you read from table, basically the Z score that you need to read is something like this. So this is 1 minus 0.9852 and equals to 0.0148. So your significance level is 2% and this is less than 0.02. Therefore, your hash knot is not accepted. Okay. So let's look at part B. Anna then discovered the IQ test is also designed to have a variance of 15 square. Sample of 6 people have take the test and IQ score are given as follows. So carry out hypothesis testing at 2% level of confidence. So now what you need to do is to find the average of these 6 people. So the new X bar would be, I need to zoom out a bit, 103 plus 109 plus 112 plus 96 plus 100 plus 104. So all these, you sum them up together and then divide by 1, 2, 3, 4, 5, 6. So that should equal to 104. Okay. So similarly, you are conducting your hypothesis testing. Your hash knot and hash 1 is basically the same. It's just that the number of samples are different. So px bar will be greater than 100 as usual. So this time your z score would be 104 minus 100. So the variance is given to you. The population variance is given to you. So what you need to do is to just use it. So this is square root of 15 divided by how many samples? You have 6. Sorry, 15 square, because the one that they give you is the variance. So once you calculated everything out, you should be able to get 0.6532. Similarly, this is 1 minus pz smaller than 0.653. Your Z score table can only read up to 3 decimals, so there's no point for you to do 4 decimal places. So when you read from the table, this is the answer 7432. So this is 2568. So your significance level is 2%. So this is greater than 0.02. Because of this, you accept your hash knot. And there's no reason for you to reject your hash knot. Okay? So based on the observation of part A and part B, what can you say about this whole test? So the question basically asks whether your answer to A and B are reliable or not. So basically what you can say is, if your sample size is small, the test is not reliable. Because coming from part B, you can see that your one-tailed test basically gives you a very large probability, which does not make sense. Which is why whenever you do hypothesis testing with all these sample, the bigger the sample size, the better. Question 3. So you have a shop that sells 2 kg of potatoes. You do quality control and check the mass of 80 randomly chosen bags, and those are the data. So investigate whether or not these are underweight. So this is again a one-tailed test. So before you do anything, calculate out what is your X bar. So it's 158.14 divided by 80. So this is 1.97675. Then you calculate your unbiased estimate of variance. This is 1/79. Multiply with 314.094 minus 80 times your mean square. So once you calculate this, this should be 0.0189. Now formulate your null hypothesis and alternate hypothesis. Null hypothesis states that your mu is equals to 2 kg, and your alternative hypothesis will be they are underweight. So now that you have done that, what you need to test is basically to test whether or not your X bar is smaller than 2. What are the probability? So this will be PZ smaller than 1.97675 minus 2 divided by the square root of 0.0189 divided by the number of sample size, which is 80. So this is PZ smaller than minus 1.513. You need to read from the table. So this is 1 minus PZ smaller than 1.513. So in the end, this is 1 minus 0.9349, or this is 0.0651, which is greater than 5% of significance level. Therefore, your answer should be to accept H naught, since there's no reason for you to reject it. Now let's look at question 4. A manufacturer claims that the light bulb lasts for average of 2000 hours. So you did a random sample for the 2 light bulbs. The length and the sum of t-square are given as follows. Test the claim at 10% level of confidence. 10% level of significance, stating any assumptions that you make. So, okay, basically it doesn't really give you the direction, meaning that it's better for you to do a two-tailed test, because the claim is that it lasts for an average of 2000 hours. It doesn't really say that it will last more than 2000 hours or less than 2000 hours. So in this case, it's better for you to do a two-tailed test. So, okay, so with this in mind, we know that we want to do a two-tailed test. So if this is a two-tailed test, so the left side is 5%, right side is also 5%. So let's look at your X bar. Okay, in this case, even though alright, let's change the symbol to capital T bar. So that will be 83895 divided by the number of sample, which is 42, so it's 1997.5. So what is your S square, the unbiased estimate of your population variance? So that would be 1 over 41. You sum all this number, minus 42 times 1997.5 square. Calculate it. So this is 9621.1 divided by 41, or you get 234.66. So now you formulate your hash knot. Basically, the mean is 2000, and your alternative hypothesis, your mean is not 2000. So for 2-2 test, basically you need to do twice, technically speaking. So T bar greater than 2000. This will be PZ greater than 1997.5 minus 2000 divided by the square root of 234.66 divided by 42. So always remember that your standard deviation is really your sample standard deviation, not the population standard deviation. So in this case, you have PZ greater than minus 1.058, or you can have PZ smaller than 1.058. So you found that in the end this is 0.855, which is greater than 0.05. So the right side, it seems like you should accept your hash knot. Now let's test the left side. The left side will be T bar smaller than 2000. So all the values that you need to do is the same. So basically I don't repeat the second equality. I can just write, Z smaller than minus 1.058. So this will be 1 minus PZ smaller than 1.058. And we know what is that value. That is 0.855. So once you minus that, you get 0.145, which is still greater than 0.05. Therefore, there's no reason for you to reject your hash knot, your null hypothesis. So that's all for this particular video. Thank you.